Hello, today we are going to go through the basic functionality of Lightnovo Miraspec software, and I'll show you how to control the miniRaman 785 spectrometer with the Miraspec software. First, to start the software, we have to go to the installation folder, which in our example is C, Lightnovo, Miraspec, and Miraspec version is 0.7.5113. We have to click on the exe file. Now the software starts. It's very fast. And in the beginning, we need to make sure that the proper configuration is loaded. And since our instrument is miniRaman 785, so we need to go to Help Set Configuration. We go to the Configurations folder, and we choose miniRaman Spectrometer subfolder and Standard 785 nanometer preset. Now we loaded the proper preset, and let's go through the functionality through all the menus and buttons in the software. Actually, the spectrometer is now connected through the USB-C port, and in order to connect it to the software, we click on Connect, Disconnect, and here at the bottom of the screen, you can see in the status bar, you can see green button that it's connected. The port is COM3. Then it's showing the device serial number 100020 and the firmware version 0.7.1. So let's maximize the window and let's go through the menu. File menu. We can save acquisition file. We can exit the software here as well. Then spectroscopy. Acquisition parameters, advanced settings. It's for advanced users. I'm not going to cover advanced settings in this video, since changing advanced settings by inexperienced users can lead to damage and loss of calibration of the device. Um, then we have plots. So running from 785, it's actually the plot we want to look at. Then you can also look at the same spectrum in wavelength representation. And actually now, when we look at the wavelength representation, it is showing the noise of the signal channel, it's red, and reference channel, it's blue. Let's close this wavelengths tab. And then we have data analysis option, data analyzer tool. Let's click on it. So when we acquire the data, we can add it to data analyzer by clicking here. Then it would be automatically added to data analyzer, and all the data files will be shown here. Then we should be able to save it. Let's go through data analyzer later. The random mapping menu is irrelevant in this case because it's controlling microscopes. Our software can control both spectrometers and microscopes from Lightnovo. Then under view, we can save the perspective. Perspective is the settings with the tabs and sub windows. We can basically save the perspective and we can lower the perspective. Then we have two themes. Dark theme is current theme, and both have light theme, which looks like that. But I usually prefer to use dark theme, and dark theme is used by Miraspec by default. Then we can clear perspectives, and console is also for advanced users. And we have covered help menu before. Then on the left of the screen, we have the parameters tabs. For example, laser parameters. I'm showing the laser 785. If you have dual device, then you have a toggle switch where you can switch between laser wavelengths. Over here, you can set the laser power, exposure time, number of repetitions. I see that it's 100. It's a little bit too much. Let's set it to for instance, to 3. Exposure time 500 milliseconds, that should be enough. Then we can have auto saving to the specific folder. When we acquire, you can choose the folder, the name of the files, and you can choose an option whether to add reference spectrum or not, and the folder name over here. Let's cancel. And let's enable the option into data analyzer. Usually when I'm working, I'm saving the data to data analyzer, and then I'm saving it manually after some preprocessing. We'll also cover preprocessing in this video. Then there is automatic processing during acquisition. Usually I'm not using that, but some users might be interested in that. For example, background correction. With background correction, we can record the background with this round button, and then we can click on the stick to apply the background correction. As you can see here, the background spectrum is not recorded, so we cancel. Then you can also apply smoothing, and there are different types of smoothing: Savitsky Golay smoothing and AS/LS smoothing, and then we have different settings for the different types of smoothing. To enable smoothing, we need to click on it over here. Let's close this. Then as well, there is baseline corrections, for example, to correct for fluorescence baseline, there is Rowland cycle, ARPLS, and rubber band. Advanced settings are available for advanced users, and it's recommended not to change them if you're not experienced enough. It's wave number range, intensity units, percents, or counts, and some advanced settings with respect to stability, reference, channel, and transmittance correction, which we don't recommend to touch. Uh, so then what else? The buttons over here, connect, disconnect, we already covered that. Then laser on, off. Then this round button is capture the data. Then this cross is to abort the capture. Over here is to save the data. Over here, show hide the settings panel. Then some uh, Raman mapping settings for the microscope. So we're not covering this because we have miniRaman spectrometer device and data analysis. So data analyzer can also be started from here. So let's start the laser. We start the laser and we immediately see two spectrum. Blue spectrum is the spectrum of polystyrene from the internal reference channel, and red spectrum is the spectrum of the sample of interest, which is located outside of the spectrometer. What we can do here, these buttons in the Raman spectrum window, we can zoom in. For example, let's zoom in on this peak. We can zoom in. We can zoom out. If we, for example, zoomed in, we can do automatic scaling. So now the scaling is done automatically. Let's switch it off, switch it off. Then what else? What we can do? We can do automatic. We can do fit to window. We can then as well do horizontal fit to window. For example, if we zoomed in and we do horizontal zoom to window, fit to window, it would be like that. Then we have vertical fit to window, it would be like that. Then we have trace lines. So if, for example, we would like to check the coordinate of this peak and the intensity, we have to click on it and it shows X and Y coordinates. Let's cancel this. Then we have plot legends, so live spectrum and reference spectrum. Then this is to save the graph. And for example, it can be saved as PNG, the screen capture basically. Then this is to erase. You see it's erased and then it's refreshed. This is to show the live sample. signal or to hide it. This is to show the live reference signal or to hide it. And this is to show the live captured signal or to hide it. Since we don't have capture signal, it's not shown. So let's hide the reference signal because we see that the device is behaving well and it shows very nice polystyrene spectrum. Let's hide it and let's put some sample in the beam. Now the miniRaman is equipped with the middle distance probe and I have some alcohol, which is actually a mixture of ethanol and isopropanol. And it's in the plastic bottle, and our device can measure it through the plastic bottle. So let's start the acquisition. Capture the data. You see it's been captured, it's gray, and then when it's captured, it's green. And since we showed the option to add data analyzer, now we need to name the data. So for example, let's call it alcohol 1. Alcohol underscore 1. Okay. Then it appears in the data analyzer. Let's record another spectrum of the same sample. Let's do it again. Maybe we can actually change the repetition count. Let's, for example, do 10 repetitions. And we can also change the exposure time. I don't know, we can do 200. And as you can see, because the exposure time changed, then the signal level also changed. And let's capture the data. And let's call it alcohol. Good. Okay, it's again in the data analyzer. And as you can see, different intensity. And again, we can maybe do other settings. We can do that. And do one second exposure time. And we can as well change the laser intensity. For example, we can do 20 milliwatts, and we can capture the data. Alcohol 3. Okay, I think it's enough. For demonstration, we can, enough of data. We can switch the laser off, then we go to data analysis tab, and over here we can hide and show the spectra. Um, in this section here, it's showing some metadata, the name of the file, device serial number, wavelengths, exposure time, and everything related to current file. Then let's just choose one spectrum, for example, alcohol 1. And what we can do here, we can actually, if the file was saved, we can open the file. We can save current file, we can save selected files. We can look at the history as well. We can do some pre-processing. So for example, let's crop the spectral range and let's crop it to the range 500 to 2000. 500 to 2000. Now crop and it created file alcohol crop 1. Um, then we can do spikes correction. So if in case we have some spikes, usually it doesn't give uh, any significant spikes, but you can there's an option to simply like that. Then you can do smoothing. So for example, Savitsky Gauss smoothing radius 4, order 4, as well as possible to do ASLS smoothing, but let's do Savitsky Gauss. And actually we see smoothened spectrum. Now it did not smoothen it. The smoothing settings were reasonably weak. Let's change the smoothing settings. For example, radius 10, order 4. And let's compare them. Let's compare them. And we see that the smoothing spectrum looks different, so it reduces noise. Then what else? Uh, Baseline correction. For example, if the baseline correction was Roland circle radius 1000, we do OK, and you see the baseline is correct. What else we can do? We can normalize. So, for example, min-max normalization. And over here, we just click OK, and it normalized, and maximum of the signal is now set to 1, and minimum is set to 0. In this data analyzer window, we can also change the color. So, for example, if we want to have it red, we can have it red. Then it's possible to do pipelines over here as well. So, for example, spikes correction, smoothing, baseline correction, normalization, everything at once, in one go. Analysis. Then it's when we collected a bunch of data, or when we have microscopy data, we can have PCA analysis and NMF, calibration, classification. We can also do quantification models. If we have libraries installed, we can do identification, identify, add spectra to library. It's possible to build user libraries and load custom libraries as well. So basically, what else? So let's just disconnect the device. We can disconnect the device over here. And of course, never forget to save your data. So for example, we select all, select all, select all the spectra, file, save selected. And it is asking to save data, and let's create a new folder, data folder, and we save the data over here. And if we check over here data, it saved all the data as TSV files, which are the format by default. And now I'll show you how the data is saved. It's just ASCII file, and there is some metadata, and basically two columns of data, wave number, and the intensity in percents, which are saved with tab separators. And so that's if you prefer your own data analysis tools for advanced data analysis, such as MATLAB or Python, you can easily load the data in those softwares. So that's more or less everything what I wanted to show to you today. You can exit the software by clicking on the cross over here, as you know, or just do File, Exit. So now we quit the software, and thank you for your attention.